Okay, so we're on to 6.2, and 6.2 is all about simple and compound interest. So this has to do all about money, obviously, because we're in the finance unit, and how either to make money or possibly to owe more money. That's what interest does. So we're going to learn about simple interest, and simple interest is a formula. So it's found right here. Okay, now I equals P times R times T, where I is the amount of interest earned or due. So sometimes you either owe interest or you get interest. P is the principal. We'll learn what that means. R is the annual interest rate expressed as a decimal. And T is the time of investment or loan. Okay, so T is time, R is a decimal that shows the annual rate, and P is principal. And then I is either how much you owe or how much you make. This formula here is just really simple. It's just saying what the total amount you have now. So A is the final value of the investment, or how much you totally owe. So you just take what you had originally and add the interest to it. Okay, so let's go down here. There's a worked out example that you can of course read through. The first bit is not too bad. So let's look at example 1. So calculate the simple interest earned on each of the following principal amounts of the rate and term given. So you can see a worked up bubble here. It's always good to represent what you have. So here we're trying to find I. Okay, it says calculate the simple interest. So calculate I. As soon as you see simple interest, you know you're dealing with I equals PRT. You might ask yourself, do I have to memorize this formula? No, it'll be on your data sheet. Okay, you can see here that our principal is 1,000. So that's what you started off with, $1,000. 5% is our rate, so that's R. Now remember, R has to be in a decimal place. So when you convert percent to decimal, what you're going to do is you're going to take your number, so 5%, and divide it by 1,000. So your percent divided by 100 equals a decimal. So in order to use this 5%, we are going to do 5% divided by 100, and that gives us 0.05. So that's what we're actually going to use when we plug it into our formula. And this is T, this is 1 year, so T is for 1 year. And we have all of our stuff. So all we got to do is plug it into our formula. So I equals P, which is $1,000, times R, which is 0.05, and then multiplied by the year, so 1 year. And what that's going to equal is $50. So your interest is $50. So it looks like that you have gained $50 in your investment. So in order to figure out how much you totally have, you would take 1,000 and add it to 50. So it's as simple as that. Now you might ask yourself, what does per annum mean? This means per year. Okay, and the harder questions that we'll go through deal with that. So let's see what happens here. So we have a principal amount. Again, it wants us to find our interest. We start with $1,000 again. Our R value, remember, it has to be in a decimal. So I'm going to take 2.5% and divide it by 100. And that's going to give me 0.025. And then this time our T value is 2 years. So we'll do 2 years this time. So to solve this, all we're going to do is I equals P times R times T. And that will be 1,000 times 0.025 times 2 years. And the interesting part is this investment's not quite as good, because guess what? The interest is going to be the same, $50. So here, this was a better deal. I mean, at least if you're making this money, every year you're going to get an additional $50. Here, it takes 2 years to get $50. Okay, so if this is an investment, this guy has only grown his investment by $50 over 2 years, where this guy grew his investment by $50 in a single year. Okay, let's move on and let's go to question 3. Okay, so I'm going to give question 3 out here. So how much money will you have after 10 years if deposited $1,000 at a rate of 4.5% simple interest per annum? So remember, this means every year you grow by 4.5%. So let's check this out. So in this case, our time, well, again, we're trying to figure out how much money would you have after this. So first off, I is not how much money we have. I is the interest made. So in order to figure out how much money we have to take our original amount, which is 1,000, and add it to our interest. So first off, we need to find our interest. So what we started with, we deposited $1,000. This means this is our principal, P. So P is going to be $1,000. Okay. R will be our 4.5 divided by 100. So that gives me 0.045. In this case, we have 10 years. So this is after 10 years. So that's going to be T. And now it's a matter of plugging it in to figure out how much interest we got on this. So I equals P times R times T. P is our initial amount, so 1,000, times R, which is 0.045. And then T, well, we have this invested for 10 years. Okay, so let's see what that becomes. Well, that is $450. Okay, and you'd obviously plug that in your calculator. I'd probably practice plugging that in your calculator. Now, this question says, how much money would you have after 10 years? This is the amount of money we made. So note that this is the interest made on our deposit. So the amount that we have is what we originally put in plus what we've made. So we have made $1,000 plus 450. So that's $1,450, and that's how much we have. Okay, and remember that equation that they talked about, A equals P plus I. So this is amount made. So we did P, which was our principal, plus our I. Okay, so that was that equation at the very beginning. So that's as simple as it gets for simple interest. No pun intended there. But yeah, give a few questions a shot, but we're going to move on, and we're now going to learn a little bit about a different type of interest, a compound interest. So a compound interest is calculated on the principal plus interest earned in prior compounding periods. So simple interest essentially just takes your original amount, takes whatever your rate is, and keeps adding on to that every year. So if 4.5% of 1,000 is $45, well, we're just going to add $45 every year. Compound interest is actually better if you're investing, at least, because it takes into account what you've made prior years and then puts the percent on there again. So there is a little bit more of a tricky looking type of equation, I guess, and that's found right here. So this is for compound interest. That simple equation that we just learned is for simple interest. So a way to kind of remember that is the simple equation is for simple interest. The compound equation is the one that's a little bit more difficult, okay? Now, A is the final value of the investment. So just note this is how much we've made, or not how much we've made, this is just the total amount. Okay, it's not just interest, it's the total amount of your investment. P is the principal, so what you start with. R is the same thing, it's the annual interest rate expressed as a decimal, okay? So recognize annual is yearly. N is the number of compounding periods in a year. Okay, and we're going to get to that because sometimes you compound per every 2 years. you compound a year by 2. So you don't get your investment at the end of the year, you get it every 6 months. Okay, and we'll talk about that in a bit. And T is the term of the investment or loan in years. So this is the amount of time or term. So let's try, you can see a work through example here if you would like to see some. But what I'm going to do is I'm going to work on example 5 for you. Here's another one work through and see how they list all of their stuff. That's what we're going to do as well. So calculate the difference between the final values of the following two investments after 3 years. Okay, so $4,000 invested at 3.5% per annum, compounded annually. Okay, so number 5 here, we're gonna work with option 1. So I'm gonna call this option 1, and I'm gonna call this option 2. So let's figure out which one's better. Let's go with option 1 and see what it results. So again, list everything you have. So first of all, we're compounded annually. As soon as you see this equation, you know you're going to use your new equation that you just learned. That is A equals P times 1 plus R over N to the power of N times T. Okay, now let's list everything we have here. So what do you start with? You start with $4,000. So P equals 4,000 bucks. R is the annual rate, which is 3.5%. So R equals 3.5%, and remember it has to be in a decimal. So this will be dividing by 100, so R is actually 0.035. Now let's look at T here. T is the amount of terms. So recognize this was compounded annually. So what does that mean? This is per annum and it's compounded annually. So that means you just get it every single year. So this is every year. So 1 year being compounded annually, that actually just makes N equal 1 because that's the amount of compounding years there is. T then means you're doing it, this asks for after 3 years. So that's 3 terms. So T equals 3, okay? Because there's 3 years and each year is a term. 1 year is a term, okay? So now we just plug this into our formula. So A will equal 4 grand times 1 plus R, which was 0.035, over 1 to the power of 1 times 3. Okay, and I'm going to show you how you'd want to do this. So you always want to figure out what this is first and then put the power of. So this will be 4,000. 0.035 divided by 1 is just obviously 0.035. So this will be 1.035 to the power of 3. And then when the way you plug this into your calculator can be a little tricky. Do this first and then multiply. So what I'm going to do in my calculator is I'm going to do 1.035 and I'm going to press to the power of, so this little power button here, and you can see we're now in a little power. I'm going to put 3. I'm going to move my thing over. So I'm going to press enter. Now I have this number. So I'll take this number, which is 1.035 to the power of 3, and multiply it by 1,000. So 1.1087 times 4,000. And that gives me 4,434.80 cents. So we've made a decent amount of money. We've made over 400 bucks in 3 years. Okay. Now, obviously they rounded, there's a tiny bit different. They got 7 cents, that's fine. Doesn't have to be exact. Okay, let's look at option 2 now. Option 2 this time is a simple interest. So remember, compounding is way better than simple. So if we want to figure out how much money we've made after 3 years doing a simple interest, well, simple interest is simply going to be P times R times T. So P, again, we're starting with $4,000. R, we have to use the decimal of 3.5%, and time is 3 years. So it's a matter of just plugging this in. And remember, this doesn't tell us how much we've made. This doesn't tell us how much we have after 3 years. This tells us how much we've made. So I'm going to do 4,000 times 0.035 times 3 years. And that will end up giving us $420. Okay, but remember, this is how much interest we've made. So to figure out what our investment is worth, we take P, so we use A equals P plus I, so we do 4,000 plus 420. So we actually have $4,420. And if we look here, which investment's obviously better? Well, this one's clearly better, okay? We've made about $15 more in the 3 years than we did with the simple interest. And recognize, if this is only 3 years, once you do about, let's say, a 40-year investment, so if you start investing really, really young, you will make way more money doing a compounded annually versus a simple interest. It'll be way bigger. Some people start investing when they're 20, and they can make about, let's say, $20,000 turn into $1 million by the time you're about 50. And if you're really good, by the time you're 40. So compounding is really important. Start investing early, everyone. So let's go a few more examples here. So the hardest part is knowing this compounded annually in the terms. So this is definitely a difficult equation. If you need some help, come in and ask. So let's do another question. Let's do number 8. And again, always read through some of these. So you have some weird words that you're going to have to learn. Annual, semi-annual, quarterly, and monthly. Okay. So recognize that changes what your end value is. Okay. So semi-annual, let's see if there's examples up here. There's not. So semi-annual means N equals 2. Quarterly means N equals 4, and monthly means N equals 12. So you can see some examples written down below. So this thing was semi-annual, so see how N is now 2? That's because you get money back every half a year. So you split a year into 2. Okay? So just recognize that. Your end value changes depending on how it's compounded. So let's see an example here. What is the difference in the annual amount of interest you will get on $10,000 deposit at 3.75% per annum for 1 year if it's compounded annually compared to compounded daily? Okay, so this is kind of interesting. We have compounded annually compared to daily. So let's do compounded annually versus the daily over here. So just think about how much that breaks your value into. So here, if you're compounded annually, that means you just get it every year. So N simply equals 1. Over here, if you're compounded daily, that means you're breaking your year up into 365 different times you get paid. So N equals 365. Both are compounding questions. So you'll use your equation A equals P times 1 plus R to the power of N R over N to the power of N times T. And over here, the same deal. P times 1 plus R over N to the power of N times T. Okay. In both cases, you have a few common values. How much are we investing? You're starting with $10,000. So P equals $10,000. R is your percent per annum. Remember, it has to be a decimal. So I'm going to take 3.75 and I'm going to divide it by 100. That's going to give me 0.0375. And now over here it changes. My N value, well, this is compounded annually, so every year, and there's 1 year in a year, so it's just N equals 1. How many terms happen in this? Well, my T value will be 1. Right? Because we are doing this, for 1 year. Okay? So we can plug these values into my formula. So A equals P, which is 10 grand, 1 plus R, so 0.0375, divided by 1, and then N, which was 1 times 1. So remember, figure out this mumbo jumbo inside, and then do the power. So first off, I'm going to figure out what this number is. So 0.0375 divided by 1. And then I'm going to add 1 to it, so plus 1. So I get 1,000 times 1.0375 to the power of 1 times 1 is 1. So I'm going to take this number here, 1.0375, and I'm going to put it to the power of 1. Remember, your power button is this button. And then I'm going to take that number and multiply by 1,000. So 1.0375 times 1,000. So this one, A, will be 1,375. Or sorry, $1,037.50. So remember, this is how much we actually have. So we didn't make too much. Now, let's see what happens when things are compounded daily. So this is going to look a little different. So if things are compounded daily, well, we're still putting in $10,000 to begin with. So P equals 10,000. R is still the same rate, 3.75, so 0.0375. Okay, now what changes? Well, the thing that changes is our term, well, we're still doing 1 year. So T is still 1 year. But what's going to change is the fact that we're breaking this year into 365 times. So N is going to be 365. Okay, so what does that mean for us? Well, this means that our equation is going to look a little different and we're going to make a different amount of money. So A will be P, which is 10,000, 1 plus R, which is 0.0375, divide by N, which this time now is 365, to the power of N, which is 365 times 1 year. So now, this is a little bit more difficult to solve. We're definitely going to use our calculator on this one. So let's zoom in here. Oh. Okay, so again, always figure out what's in the brackets first. So first I'm going to do this. I'm going to take 0.0375 and divide it by 365. So I could do a really ugly number. Okay, so what you're going to do is you're going to just press 1, or you're just going to add 1 to that. So if you just press the plus button, your calculator's smart enough, it'll take the last answer and add 1 to it. Okay, so there is our number there. So we have 1,000 times 1.00010,274, and 365 times 1 is 365. So now I'm going to take this number and I'm going to press the power button, and I'm going to plug in 365. Okay. And what I'm going to do from here, so far we have this now 1.03821, and I'm going to multiply that by 10,000, which I think, yeah, so I missed a 0 on my 10,000s here. So I'm going to multiply this by 10,000. Okay, and what we get is $10,382. So what you can see here is look how much more money, well, he didn't make a ton more money, but we still made $1 more because we compounded daily, okay? So even though it's the same rate per year, compounding makes you more money. Okay, so in this case, it's not a huge difference, but again, when you start talking about bigger money over longer periods of time, you start making way, way more. Okay, let's do a few more questions here. So that's how to do compounding questions. Let's look at a new rule. Okay, so this rule is known as the rule of 72. And a rule of 72 is a way to estimate the time it takes for an investment to double in value. So it's really useful to know, and it's a really easy equation actually. You just take your interest rate and you take 72 and you divide it, and that's the years to double an investment. It's just a simple estimation. So let's see it here. It's not too bad. So use the rule of 72 to estimate how long it would take the following investments to double in value. So $1,000 invested at 2.45% per annum, compounded annually. Okay, well, all you're going to do is you're going to take your percent rate, and you're just going to take 72 and divide it by, but remember, it has to be in a decimal. So I'm going to take this and divide it by 100. So that'll give me 0.0245. Oh, sorry, never mind. That's the weird part about this this equation. You actually take literally the percent. You don't need to change the percentage. And that's like the only time you never ever do it. So I'm actually gonna just leave it as a percent. Okay, and here you will get 29.4. So here it's 29.4 years to double your initial $1,000, which isn't too bad. It's pretty bad actually. It takes 30 years to make you get $20,000 or $2,000 from 1,000. But I mean, money's money, I guess, right? So here, how long will it take me to double my money if I only have a 1.95%? So 72, and again, this is the rare time you don't turn it into a decimal, and that will be 36.9 years. Okay, so it'll take 36.9 years to double your investment if you're only making 1.95% annually. Okay, so here's a few questions that you can practice. Okay, so we've learned how to do questions like this. It's just a simple interest example. I'll do a few more here, and then you can go from there. So let's maybe skip 2. And the last question I'm going to do with you guys is not 4, because 4 you actually might be able to do here. So compounded daily, you can try this one out on your own. So compounded daily, remember that's n equals 365. In this case, t will equal 3, right? And you're compounding. So you're going to use your friendly equation, 1p times 1 plus r over n to the power of n times t. So you should be able to do this one. P is your principal, so 4,000. R is your rate, but in a decimal. So in this case, 3 divided by 100. N would be 365 because you're compounding it daily, and T would be 3. So give these two a shot. See if you can get these solutions here. I'll do this last question, and then you can be happy and leave and try some questions out on your own. Okay, so calculate the final value of an investment of $5,000 over a term of 10 years and a rate of 2.6% at the following compounding periods. So here we're compounding every time. So we're going to use this equation each time. Just recognize R is going to stay the same for all of them. So all of them, they're going to have the same rate, which is 0.026. Remember, 2.6 divided by 100. They all are going to start with $5,000. They're all going to have a term of a time of 10 years. What's going to change is your N values. Okay, so annually means N equals 1 because it's just every year is a year. Quarterly means you're breaking it into fourths. So B, it'll be 4. Monthly, well, how many months are in a year? Well, that's 12 months in a year. And then daily, well, there's 365 days in a year. Okay, and then you're just using this equation over and over and over again. So A equals P, or let's plug it in properly. So $5,000, 1 plus R, 0.026, divided by N, which is 1 in this case, and then to the power of N, which is 1, times time, which is 10 years. Practice plugging this in your calculator. See if you can get it properly to equal, I think that's 6,000, but I can show you how I would do it. So again, figure out what your inside is. So 0.026 divided by 1, add 1, and now I'm going to press to the power of, and I have that to 10. And then I'm going to, now this number is equal to this entire thing, so I would times it by 5,000. So there you go. There's $6,463.14. Okay. Try this one out on your own, or try it out and see how it goes. So this should say A here. So A would equal, again, $5,000. 1 plus, what's my N value here? Well, it's quarterly, so that's 4 on the bottom. The rate stays the same. And this, instead of N being 1, well, N is 4, right? N is 4 since it's quartered, and it's still for 10 years, so times 10. So this will be 5,000 times, let's figure out what 0.26 dividing 4 is, and then add 1 to it. So I get 1.0065 to the power of, and now 4 times 10 is 40. So I'm going to take this to the power of, remember, power button, 40. And then now, what am I going to do? Well, this is 5,000 times 1.295, blah, blah, blah. So times that number by 5,000. And that equals $6,479. And you can see that answer there. So try and do these last few questions out on your own, at least plugging them into your calculator. Okay, so in this case, P is still 5,000. The rate is the same, but this time your N value is 12. So it'll be 12 times 10. See if you can get the proper solution here. Okay, and the same thing here. A equals 5,000. 1 plus 0.026 divided by 365. In this case, it's 365 times 10. This one would be tricky to plug in your calculator, so make sure you practice. Try and get these solutions here. Okay, if you have any questions, please come in and ask. Throw me an email or come into class, see how things are going, and do any whatever assignments that you're given to complete. Have a good day.